Hello and welcome to Cyber Insanity, the podcast for cybersecurity with Andrew Berkuta and my co-host.
Angelo, Longo. How you guys doing?
Doing well. Well, today we have an all-star panel on a topic I think is so relevant today. Angelo, what is our topic today?
Tokenization. The fall of encryption and the rise of tokenization. Or did I just rename everything?
But not just any tokenization.
Yes. Rixon.
Rixon Vaultless
Vaultless
Tokenization.
tokenization. And that's why we have these great people here.
Right, because I think there's a lot of confusion in the industry today on just what's effective. How do I protect my data with the emerging threats today? But also, what's the right choice? So, Angelo, introduce our panel, would you please?
Well, I want to introduce George first because she's my favorite. No, I'm kidding, guys. But let's start off with Georgianna, Dr. Georgianna Shea. Would you like to introduce yourself?
Sure. Hi, everybody. My name's Georgianna Shea. I go by George. I'm the Chief Technologist at FDD, which is the Foundations for Defense of Democracies. I've been working in computer network operations, cybersecurity, I'll say more resilience now for almost 30 years. And I'm honored to be here. So thank you for having me.
Thank
Awesome.
you. Let's go with Justin. Justin, introduce yourself.
Yep. Good morning and glad to be here, everybody. My name is Justin Hatcher. I'm a technologist of 23 years. I've been CTO of Rixon for 9 years and am also a co-founder. And I'm looking forward to finishing my PhD in a few more months.
Awesome.
There you go. So I told you, all-star cast. And Doug, please introduce yourself.
Sure. Doug Lambert, CGO for Rixon. I've been working here for about 4 years. And basically, my background 20 years in finance, financial services, and degree focused on fintech and the new economy. So, really focused on how finance is evolving.
Awesome.
Nice. So, Doug, you mentioned fintech. This is really a heavily attacked industry right now, I think. Why did Rixon come to be? I guess why are they here today? Why are they just so causing such a stir in the industry?
Well, I think the key issue is I think everyone thought there was going to be a simplification of like payment services, like fintechs are going to come along, there'd be some global payment system. It would be great, it'd be trusted, verified, there's some blockchain, and everyone thought you would just sort of operate around the globe. But in fact, as we move to mobile payments, new processes, it creates new problems, it becomes more complex. I would throw in a couple of things. One, if you think about it, it's not just about protecting credit card fraud, but AI has two sides of a coin, right? So as AI comes around, the fraud gets better, right? They become better at getting in your systems. Two, payment systems are becoming more complex. So like if you think about it, you have agentic e-commerce coming around. But on top of that, you also have sort of these regional data and sovereignty laws that make it very difficult to operate sort of cross-boundary through different countries. And I think overall, some of the existing systems, some of the tokenization systems, some of the even security systems aren't really designed to help you solve some of the complex compliance problems or privacy regulations in an easy fashion. So you have this problem where you're trying to do this new product, users love it because it could potentially be easier, but it's very hard for the companies to sort of operate it and manage it effectively. And to top it off, everyone requires more speed, better security and more speed. So
Ooh,
there's some issues there.
Okay. So that's the magic dagger there, right? That's the golden trophy here. Speed and efficacy.
Yep.
George, is that possible?
That's loaded.
I mean, is a loaded question, but I mean, in 2025, we're seeing indicators that things like the things we hold near and dear, things like encryption, for example, that they're being questioned. And how, why now? What is causing this disruption? Why are we second guessing ourselves?
Well, I don't know if we're second guessing ourselves, but we're more aware of the implications of the advances in technology. So, I mean, you could put yourself in the mindset of, if you were in the 1960s, which I was not alive in the 1960s, but look at the computational power in the 1960s and where they thought we'd be today. And it's not anywhere near where they thought we'd be today. We've surpassed that by 1,000-fold. So we have the same mentality. Where do we think we're going to be in 10 years or 100 years? And we think it's going to be here, but more than likely it's going to be much further along. And we're seeing these advances in technology at, I don't say an alarming rate, but a realistic rate. So right now we're looking at, I don't want to say quantum computing, and I don't want to confuse people because we currently have quantum computers. But we don't have quantum computers that can currently break our modern day encryption like RSA and ECC. But we're approaching that period. And when we have quantum computers that can break our modern day encryption, that's known as a CRQC, a cryptographically relevant quantum computing machine. So I just want to distinguish, I'm not going to say quantum computers aren't here yet because they are. I'm specifically talking about CRQCs. So I find that in the cybersecurity industry, a lot of industries, a lot of CISOs, a lot of folks, they do what they're told and they do what they have to by compliance requirements. And so we're seeing that on in the United States, in the European Union, across the world, because policies have come out, regulation has come out to now start to transition to these new algorithms that we believe will not be susceptible to a CRQC. And I say believe because, again, it's based on the assumption of what we think the computational power will be in the future. I usually have to, caveat whenever I'm talking to people about this because this isn't going to be a one and done, fixed it, you switched from RSA to Crystal Kyber and now you're good forever. No, we believe Crystal Kyber will go through and mitigate up to a point in computational capability, but then as technology continues to advance in the future, like it has, then that will probably have to be replaced as well. So under those, federal guidelines, policies, we're right now in that position of everyone needs to start switching over to these algorithms. So if you're a more proactive cybersecurity person and you're not just doing what you're told according to the compliance piece, you're looking at the bigger picture here and you're saying, okay, how do I get to the root of the issue to ensure the security is going to be forever? Or how can I ensure more security? And even with the vulnerabilities of the security, it's not always just the encryption itself that we're worried about. It's all the practices in that process around the encrypting, the handling of keys, the getting the information into this encrypted state, and the different, I guess, attacks that you can go through and expose that kind of data. So if we can, again, get to the root of that's really what we're looking for. So I don't know if that answers your question, but that's where we're headed right now. It's kind of a world frenzy on make sure we're going to be mitigating these CRQC issues.
That
I just
really
want to use CRQC in a sentence someday. So
that really comes down to it almost sounds like built-in obsolescence, right? And it's not from the manufacturer standpoint, it's really from just the trends and the tools that are available to make something less relevant or less effective.
Mm-hmm.
Justin, now my question comes to you because we know encryption in the past, as George had mentioned, that things like tokens, like RSA tokens, and all these things. We used to use those. They used to be little fobs or whatever. Now those are gone away. And then we used maybe hardened, 256 type of encryption. And now all of a sudden, is that not going to be enough if I'm looking at the crystal ball and saying, this has been broken. This has been reduction in time to crack crack something. Now we have these supercomputers on steroids that are going to fit under a desk at some point. My crystal ball tells me it's not sustainable. We can up the 256, 512, insert your counters here, but at some point we're chasing a rabbit we'll never catch.
Yep.
But then we hear in terminologies tokenization, and then we're talking, well, there's a right tokenization, and then there's a not so right tokenization, right? And
Right.
I'm queuing up Rixon a bit because you're very different. You're vaultless tokenization, and there's a distinction between vaultless and vaulted tokenization. Could you kind of explain in a nutshell the difference and why one is a more superior thing? Because we did talk about speed in the beginning.
We did. Thank you. So yeah, if we look at that dichotomy between vaultless and vaulted tokenization, historically, the way tokenization worked is you took that clear text value, you encrypted it and stuffed it in a database and generated a non-relevant random value that you use that as a surrogate value to reference that encrypted original value. And that tokenization, the security that provided is that if as that token, that replacement or surrogate value it traverses all of the vulnerable or the people, processes, and technologies within an organization that serve as different attack surfaces. As it traverses that, if somebody were to capture that by one of the security vulnerabilities that we know of, it's a token and therefore not reversible or not the original data that it stands as a replacement value for. So that's the overall security model of tokenization. And historically, all of that is managed inside of a database or what we call token vaults. And there's lots of providers out there that provide these vaults. Now, the overall philosophy there is that if I take my sensitive data and I put it in one of these vaults, it's supposed to be hardened, it's supposed to be secure, it's supposed to follow all of those standards with encryption and key rotation that auditors have put in place. And again, the genesis behind all of these policies is as we find these security holes, we like to say, okay, well, we need to plug that, and encryption is a nice little plug that plugs that hole. And we've come to a place where a lot of the holes that we know about are plugged with encryption, and they're sustainable now. There's a lot of holes that we don't know about, which is why we see, especially in the breaches still happen on a daily basis, worldwide. So it's policy wise, we've been stuffing these holes with encryption, and like George said earlier, with CRQC, excuse me, with that. With that on the horizon, those plugs that we've had in all of these security holes are knowingly going to become weak and knowingly going to be unsatisfactory to keep that data secure. So coming back to your question, the vaulted model uses all of these security pieces to keep that data safe and generate surrogate values that then are traverse those people, processes, and technologies. Vaultless doesn't have that treasure trove of a vault or a database that can be stolen. It's not another single point of failure. Instead of it being in a database, it is a computational algorithm that replaces those values with non-deterministic tokens that can be used in the same way. The difference is, again, there's not a persistence layer where that data can be stolen. There's not a persistence layer where you're managing the keys and the rotation and all of the things around encryption. And it's extremely fast. You're no longer bound by the I/O of how to read this information from a database, get that back to your user client to interpret or translate that token back to the original value. It's rather than being I/O bound, it's determined by compute power. as George said, our the threats are becoming more and more relevant because we have advances in computing power. With vaultless tokenization, those same advances in computing power actually make the system faster.
Interesting.
I just
So,
want to jump in real quick, and
Awesome.
I just want to make sure I know both I and Justin and I talked about the CRQCs and the threat of that being on the horizon, but I didn't explicitly say that that's a threat today because there are what they call hack now, decrypt later attacks going
yeah.
on. So if your data isn't being protected right now, even though we don't have a CRQC, there are organizations out there that are sweeping up this information and putting it aside and waiting for that capability, and then they'll be able to decrypt it. So it's not a wait until it's an issue. It's an issue now.
Absolutely.
That's a
Love
good
that.
point because from a CISO perspective, Angelo, when you go into an event where somebody steals something, having a vault of anything, encryption, tokens, or whatever, that's still not the panacea here, is it?
Because it highly depends upon what that encryption is. I don't know if you guys notice it, but I have a little gray hair. And that gray hair did not come from being a happy-go-lucky cybersecurity consultant. It became when I became a CISO. And part of being a CISO is the fact that you need to worry about where the data is, what it's doing, how it's working, et cetera, and how it's encrypted, how it's secured, how it's restricted. And all those things come into play. You could have something that's encrypted that's completely decryptable in an hour or so. The issue at hand comes down to how much effort did you put in encrypting it, how much effort was needed to access the data when you needed it, and how much and why you chose that encryption standard because of speed. When you start looking at having a vault, that vault matters because that vault may or may not be something that is actually of definable and usable for somebody to take down. But even if they do take it down and capture it and take it out of your organization, the real question comes is, can they actually pull anything out of it? And if you cannot do that, if there's no way to get back to where you began with, they don't have anything but a some random code that they can't do anything. That makes me happy. The thing that doesn't make me happy is finding out that stuff that you have sitting on your servers, stuff that you have had transferred in email, stuff that you've had transferred in other methods has been in an encryption method that was not adequate. And now what do we do? Go back and find it, try to get rid of it. But my data has been exposed or will be exposed. And so my worry still stands from there. Does that answer your question, Andrew?
It does. All right. So this now brings a new question because it's all people, process, and technology that we have to gravitate around. But I think there should be another layer. Probably it's called the auditor, right? In order to embrace new technologies, and let's pick on fintech again here. If I was a CISO, if I was a CEO or any board level person, the first thing I'm going to say is, how's this going to affect my audits? Right. And so George, I'm going to pick on you again because you almost have the conversation when you talk about vaultless tokenization. Everybody understands, okay, if I have two Scrabble boards and I substitute this letter with this letter in these different boards, this will become my token. Great. Okay. But then can we prove it? And now we start talking about a definition, I think it's called zero data architecture. This is technical, but this is proof. Can you explain what zero data architecture is and how does that translate to, is this effective?
Sure. So I would start by talking about zero trust. So you have zero trust. When people hear that, they usually, start talking about the overall architecture, segmentation, ensuring that you have the continuous monitoring of where you have trust, authentication, things going on. When you get to the data piece of it, again, the core thing that you're trying to go through and secure, you if you've tokenized it, that the data's not there. So you've already removed the having to I guess the exposure from hand to hand as it's passed along. So I don't know a better way to say that. I guess the hand to hand as it's processed. So I don't know if I'm doing a great job explaining exactly the phrase that you gave, but it gets to the, like I said, the root of the issue of if you're transmitting the data, yet it's not in the readable, understandable form, then the data is not there. One of the, I guess one of the big compliance issues that people look at is the GDPR and the right to be forgotten. And then where is that information within your system? How can you find it? So if you have that data, and let's just say you've tokenized it, you don't have that data. It's if I were to be a man in the middle, attack this at any point within the system and then pull it down and say, okay, I've got your information. I open it up. I have useless tokens. There's no actual data there. So the actual data that you're taken in gets morphed into something differently. So it doesn't get exposed to those man-in-the-middle attacks, the super user, the insider threat, the people who don't need to look at it. So it gives you a tighter security around that core piece, not just the I guess I can describe it as like the outer perimeter of the data, but the data itself is now, changed and morphed.
Okay. So I'm going to pick on Doug now because if what I'm hearing is if my data is, let's say, stolen but not unpackaged, right, and not touched, there's somebody storing it because they're going to manipulate it maybe offsite or something. We're just stealing the tokens and it's a non-event. Is that what I'm hearing?
Not stolen.
That's right. That's right, because they're not going to have access to a key or the lookup tables to convert that data back. And I'm sure Justin can go deep into the details about segmented security and how we operate.
We'll pick on him.
Yeah, absolutely. Do that. Please do not do that to me. Thank you. But, it becomes a non-issue if you think about extortion or re-extortion as it relates to breaches. But I also think the big thing to note here, especially, again, I keep going back to fintechs, is that you're really reducing your scope of compliance. If you're a vault, you don't have a third party storing new data because Rixon doesn't store any data. If it's PCI, fine, you're not storing credit card data, so that helps. If it's GDPR, we can set controls where, regional controls, so only that specific country can read or access that data. And not only that, but in our audit trails, we can tell you who is actually reading the data. And we have an AI machine that actually can tell you if there are patterns where the data is trying to be accessed. So there's a lot of things we can do to just make life easier. Especially, when I think about it, I think about high-speed financial transactions, whether you're being audited, whether you're a company who's trying to meet the PCI standards and the GDPR standards and get your business going. And there's also some really important benefits related to speed and cost savings for Rixon as well. So I think it's not just about the security and the security we're doing today. I just want to note, like I think it was 2023, global fraud is at 43 billion, right? So you're doing the things you're doing today, and there's still $43 billion 2 years ago of global fraud. Now you introduce an AI, the fraudsters get better, smarter, they have more powerful computing, they have better ways to get into your systems and get your keys. I just think there's an opportunity for some businesses, depending on what they're trying to protect, to try some new things.
So, Doug, I just want to point out that you'd mentioned, you kind of just mentioned it, but I don't think it was really brought up in the description. So, we talked about tokenization and how it, changes what the data is, so someone gets it, and then you reference the policy around that, so the geotagging of it. One of the things I will say that I love about the Rixon tokenization process is that policy engine, that allows you to put the parameters on top of the token aside from just the changing of the data. So I can't read what it is, but now I can put very specific controls on top of that. So if it is outside of a geographical area, it doesn't work. If a certain user or whatever the policy is, you can layer on other type of rules on when the token can be used and not used.
Yep.
And to your point, if it is stolen, it's just worthless. I with defense especially, it's very important to approach everything from a layered approach. Generally you have your perimeter, you have your network, you have your system. This really again gets right down to the data. It's the layered protection all the way down to the data specifically. So I just wanted to highlight that policy engine piece.
No, I think that's important because when I sort of think about tokenization, let's just even think about it as like a cost per token on the transaction basis. I think that'll be commoditized. Like, Justin built a very efficient, sort of elegant machine that can operate extremely fast and produce those tokens. But I think what really separates us beyond that, and that's very important, is you're right. The policies and the additional features, security features added on top of that tokenization also delivered efficiently. So, I think if we can, get people to understand, the technology itself, but how it benefits them beyond just the tokenization, I think that's a really important point. So, great, great add-on. Thank you for bringing that up.
Absolutely. Um, okay, so I'm gonna harp on the auditors a little bit, and this is Justin and Angelo. I think this is gonna be a combo round because um everything comes back to, is this defendable to an auditor? Does it satisfy the requirements? Will it pass the auditor's inspection for a compliance requirement? Um, have we run into that? And I think, to to Justin, probably more so, is you can prove this mathematically that this really works, can't you?
Who do you want to answer first, Justin?
Oh yeah, let's do the math and then go to the auditor, Angela, because that you're not getting off the hook on this one.
Yeah, so I think an important distinction between something like encryption and tokenization, whether vaulted or vaultless, is auditability. With encryption, I can take that value. I can go away from monitoring, away from any kind of audit, and I can spend brute force time to crack that independently of anybody watching me. Um, and so you really don't have this concept of auditability with encryption, and again with the the strength of that encryption continuing to be diminished as computational power increases. It really is a danger to encrypt all of this stuff and not really know, has it been hacked? You don't really have a point to reference when it is exposed or breached. With Rixon's vaultless tokenization, every read attempt is audited, so we know from again who, what, where, when, how, and why data is attempted to be accessed. When is it successfully detokenized? So we have that layer, that policy layer, which is providing uh, that immutable audit history of when data was accessed, and when it was successful, when it was not. And then again, as Doug said, we're able to put that through a AI monitoring system that can check for pattern recognition or anomaly detection on, is there advance notice? Is somebody attempting to read data that should not be attempting to read data?
So Angelo, it sounds like it would pass muster, would it not?
So let me give you two aspects of this. There are auditors who look at a list and say it's not on the list.
Mhm.
And that's part of the issue with some of this, is this needs to be socialized as to the importance of it and the efficacy of it. Because it's not efficacy they're testing there. It's, is it on the list? Do you have a policy for that? Do you have you implemented X? All those things. It is not a thing. So if I'm looking at this, there's two ways to take this. One, you can start with the auditor and go, listen, we have something better. And you can try to explain why. The other thing I've seen done is, hey, I have encryption, and then I tokenize over top of it. So basically you're just putting a blanket encryption in, but that really comes down to the fact of probably more stationary objects than in process objects, structured data rather than unstructured data. Excuse me, unstructured data rather than structured data. Structured data going in and out of systems, you're relying upon speed most likely, and then you're dealing with how you get to it and stuff. So there's a pattern you have to develop. There's a thing where you have to explain. You have to go through and really kind of give them an idea of why these things are important and what the added benefits of it are. Because most people just don't know, and they don't care to know. They just care to see if it's on the list, and it's unfortunate. And again, I shouldn't paint that blanketly because I'll get in trouble someday because somebody go, you said it was just on the list. That's all I'm looking at. So
Well, that's what I said too. They just do what they're told to do. So if it's a part of the compliance, that's what they do. Like,
Yep.
am I compliant or not? Yeah.
No, you're right on. You're right on. And a lot of people want to get in and get out. Yeah. So that's part of the issue.
Well, and in a previous series, Angela and I explored that topic with a cyber attorney, and she made a very good point. Is anytime you have different laws and different types of requirements, it's always after something happens, right? Here
Right.
with Vaultless tokenization, this is a proactive approach to prevent any type of event, be it ransomware, be it data theft, or absconding with somebody's data and trying to decrypt it offsite or detokenize it offsite. If you do vaultless tokenizations, there's no token vault to attack. There's no brute force that you can potentially go against it. Like if I had a bigger hammer, I can crack this tough nut called encryption. This is really rather a refreshing, proactive approach at protecting data. I think the other important thing is, and this is kind of going from my DLP days or data types of projects, is you don't have to, and I say this, you don't have to categorize the data to tokenize it, which, let's face it, one of my favorite sayings about data farms and such is we in the IT and security sector, we're the best pack rats, right? We love to squirrel away data. We never get rid of it because we can use it for something later on, but we just don't know what. So if you envision this as a big garage and somebody says, okay, we have to do a garage sale, go in the garage and start putting stickers on everything and put a price on everything, you're going to go mental. Because your garage just got bigger. Every year we spend more on drive space and server farms, and we used to call them server farms. Then there were data lakes, and now what are we going to have? Oceans and planets and stuff like this. I'm sure it scales. Data scales, and it never goes less.
But Andrew, I'm gonna disagree with you a little bit with what you just said.
Let's go.
Okay, so the data categorization is a big deal to people, but you said you don't have to categorize the data. I believe that you do. Either you care about the data or you don't, and that is really the decision you're making.
True. And let me counterpoint something here. The data that I've seen, and I think we're getting better in trying to purge that data. But you can cite research data or projects from yesteryear or previous types of enterprises where they were trying to go through either through research, through marketing, through whatever. It just never purges. It just never purges fully. There's always something that somebody goes, I will need this at some point soon. Or, hey, I like the template of it. Forget the data about it. I just like the template in something. But the data itself, it's difficult it's difficult to have somebody do a full purge on this stuff because you have to understand what data you have as residue to purge. And it may be a testament to people's data hygiene and maybe an indictment thereof, but it's never fully purged the way you ought to have. It's always retained in some type of residue. And in that comment, where you don't have to quantify that necessarily immediately, I agree with you that we still do have to know what's in our data farms, in our environment. I just think we do a bad job of quantifying what it is that
I
we
want to
have.
add to that real quick. And it stems from the frameworks that you work with that drive cybersecurity posture are done in such a way that you are supposed to know right off the bat what's on those, what you have on your network or what do you have on your infrastructure, what is on what you have on your infrastructure, and who has access to it. Those basically help you understand what your exposure are. The problem is this is some of the hardest things to determine because who moved what where, unstructured data. I mentioned that before. What was that? And so some of this is, how about we just, err on the side of caution and just lock it down before even knowing what it is. And I think that kind of gels into that conversation we were just talking about. Would you agree?
Yeah, that's exactly what I was saying. I mean, usually you have to know, is this, PCI data? Is this GDPR data? Is this FCI, PII, PHI, whatever it is. But if you don't care, then you're not going to put the effort into it. So regardless of the type of data, if you put it into the category of I care, it's under that umbrella of tokenization and it's protected regardless of the type of data.
I think just for a practical matter, at least, you've worked on, global data programs. They last 5 years. You go through your data definitions, your governance, you track it all down. It's extremely expensive. Not saying, it's not completely unvaluable. My only point is the risk remains while you do that. So if you tokenize the database like day one and say, then we'll start this program, at least you know that you may not know what's out there. You may have, it may be a requirement, finance or something, government. You may have 30 years of data sitting there, but at least it's tokenized right from the start of your 2-year program.
Right.
And then you can go through the work of finding and everything like that. So, if there's legacy architecture, old database, compliance requirements, whatever it is, we've said this. I'm not sure everyone takes our advice, but we've said tokenize it first, because at least when you get audited, you can say, hey, look, we've tokenized everything, all the relational data that we think is sensitive. We're going through the process of our governance and definitions and et cetera. So just throwing it out there as a best practice, maybe.
No, I love that. And again, I want to make that reiteration. A lot of times, and this kind of dovetails into that conversation you just had or statement. A lot of times everything is great in the structured program with definitions and ideas and such. It's when, and I hate to say it, but when marketing gets involved or when data scientists sometimes get involved, they want to see the data in a more raw format. And then comes into the question is how do they get it? Who has access to it? And what happens afterwards? That Excel spreadsheet, that SQL database that's out there for looking at the, whatever the exposure is, what happens afterwards? What do we do? And I like the fact of, if we find it, tokenize it, and then worry about what happens later. It's sort of like the shut off the lights and see who's still in the building type of scenario after they bump their knee kind of scenario.
And I'm not recommending this, but a lot of times you don't know who's accessing the data.
Yes.
So if you tokenize it, you start to find out who needs access to the data and why. And then you can determine if they do need access, you can give them detokenization, and then you get that auditable trail of these are the people who can use the data, and then we can also mask it. So we can mask by role or do whatever we need to do for that read function on the detokenization. So again, just putting it out there in practical terms, I know people don't love the system cutoff as finding out who needs access to the data, but sometimes that really works.
Well, here's I guess the follow-up question to this, right? Best practices, because it seems we're dabbling in best practices now, right? And traditional methods were find out what data is, find out where it's stored, who has access to it, inventory it, and then let's put a categorization to it as the confidentiality meter on it and saying, is it confidential information? Is it public information? What? And then we judiciously protect those highly sensitive data pieces and segments. I think part of that was because of cost and the speed of finding the data and undoing what you're trying to do to it. But I think vaultless tokenization changes the paradigm a bit. And this is where I was trying to lead to is what's the harm in tokenizing your data and then going back and trying to categorize it? I think it would be far better to protect it first. And I'm poking a bear here. Protect it first, even if you don't have the manpower, the budget, or the speed in which to find out what it is, who needs access. If you tokenize it, it kind of helps solve some of that risk problem of, hey, whoops, we forgot a piece of data, and now somebody has it, and now we have to send out a public statement or two, or to shareholders or whatever, that we had a breach. Is this the best practice we're looking at now? Is tokenize it because it's the speed is there, the affordability is there, and the breadth of coverage is there.
Well, let me say something real quick.
My experts.
Well, let me say something real quick.
Yeah.
It would be very nice to start with the premise that we're going to start secure. But 99 times out of 100, we're coming into a situation trying to figure out what's going on. And, you go to an established business, you're establishing a cybersecurity program, a DLP, data loss program, data privacy, whatever it is, you're trying to figure out what stuff is where and how it's it. That's the important part right there. Because if I can't figure out what's where, then I need to just err on the side of caution, because I have to remember that, I'm a hospital, so I have PHI data. Where's it at? I don't know. So why don't we just start with everything and then backtrack? And I'm being a little facetious, but that's a methodology that you may end up using, because the simple fact is you need to ensure security, especially in the event of something occurring, like let's say some type of B word. And I hate to say B words, but that could happen.
Right.
You're reacting to it. So that's my first 2 cents. Let's hear what somebody else has to say.
Well,
So I would add on to that, and it's not just the compromise that might happen. It's not just the data exposure that happens. We have new policies and regulation almost every single day. I mean, you just named a couple. There's a dozen. I don't think we're done. So I mean, companies will continue to be under the jurisdiction of the guiding regulation that says you have to do this, and you can expect that that's going to be more data protection in the future for different industries, whatever it is. So it just makes sense to start securely. To get to your question, this is a best practice. When I hear best practice, I almost like I instinctively think there's been a poll that's been conducted with everyone, and this is what they're doing, and then this is their best practices. So from that standpoint, I would say no, because I don't see everyone doing this, and it's not going to come up on the poll. However, it should be a best practice. People should be doing this, but I don't see the technology, specific technologies like this, these I guess disruptors in how we do things, making it into mainstream strategies. And when I say mainstream, I'm talking, you're in a computer science program, learning how to build out architecture, cybersecurity program. It's going to be go to NIST, follow the cybersecurity framework, and it's not specifically mentioned anywhere, so people aren't going to know about it. You're not going to know about it until you've lived it, worked with it, talked to somebody who's using it. So from, again, that regard, it's not on the list because they don't know to use it, but it should be.
Mhm. If I like kind of pull this around to a term that we discussed earlier, zero data is really encapsulating the philosophy here. That is, tokenize it all. And then whenever you have that auditing event, you're able to say that in a huge swath of your infrastructure, your people, your technology, network, processes, don't have, they're tokenized. They don't have the data. So those auditing events, are you using TLS with strong ciphers on this place and all of those checkboxes? It's really a game changer and saying that you can follow those checkboxes if you want, but there's no data in these people, processes, and technologies. The places where data exists is at the point of use or at the point of egress into your organization or ingress into your organization or egress out of your organization. So you're able to collapse all of that the attack surface and risk profile to very small points within an organization, and everything outside of those points is zero data architecture. There's not data there that needs to be protected, not in any kind of clear text or exploitable form.
Can I make one small point there?
Mm.
When you say organization, we need to define that as maybe solution rather than organization, because organization boundaries are very ephemeral at this point.
Mhm.
So I hesitate to your data lake sits in whatever a cloud infrastructure that you access via whatever methodology you've deemed necessary to access it. You have APIs, you have all kinds of stuff. I think the solution needs to be that, unfortunately, we've lost our firewalls, we've lost our,
Yeah.
nice clean boundaries. So,
And
it's small no nuance, not nothing. Go.
Right, Angelo. And I would have to say that the dimension of technology is also becoming very vague as well. I mean, so every company uses some SaaS product of something, which means their data leaves their responsibility. Pseudo responsibility is somewhat in the custody of somebody else. But if it's breached, I still have to announce that or provide that notice. So the whole dimension of where is it my responsibility and where do I have the due diligence to protect data is very vague and muddy all across the board, which again comes back to zero data architecture where you're not having to track, you're not using this DLP process to understand where all my data is throughout all of those dimensions of technology, people, organizations, and business. It's all tokenized and all natively protected at that data element level.
Hey, Doug, this goes back to an analogy that we were talking about, right? If I want to go swimming in an unchlorinated pool, how do I chlorinate it? I throw the puck in there and let the filter and the chlorine disseminate across all of that water, right? If the data is my water, let the pumps, let the workflows and everything start tokenizing in your organization. And at some point, it's swimmable, right? You can go swimming in the pool. I mean,
That's right.
this is where we're trying to say is throw the chlorine pucks in the pool and with less time than trying to do with an eyedropper at every square inch of water, you can do a pretty good job of protecting your data in a short amount of time and go swimming quicker.
Right. And I think with technology now, the pool keeps getting bigger because there's going to be new workflows, right, that need to be protected. You're going to add things, not to mention the fact that you're creating new data sets that could be personally identifiable. They could be related to transactions. Regulations change. Think about some new wearable that gets diagnostics that
Oh
it
yeah,
never has happened before. And now all of a sudden, these type of diagnostics are, considered PII.
yeah.
So what are you going to do with all of this new data set and these new requirements when you have a neutral sort of policy-driven security and compliance layer that you can add in, no vendor lock-in for complex workflows as you evolve, as you change? I think it can make your life much easier if you choose to do so. But that's really up to the businesses that are operating.
Fair point. Well, folks, we're coming to the bottom of our show, but I really want to do a round robin of final thoughts and from each one of you, because I think we've covered a lot in this topic, and I am so pleased that we had a little debate, we had a little bit of clarification and understanding. So thank you for helping me understand that. George, you want to do the top of the batting order and share some final thoughts?
Sure. I think the proven strategy's always been defense in depth. So make sure it goes all the way to the data level.
Great point. Justin, how about yourself?
Yeah, well, Rixon is going to enable our customers to be able to protect their data no matter what shape it's in, no matter where it is in the country, no matter what policy they're trying to adhere to. So Rixon is the solution, and specifically Rixon Vaultless Tokenization.
Perfect. Doug, how about your final thoughts?
I think my final thoughts are, I just want to make it clear to everyone that we're not competing against encryption. My advice is use your encryption the way it's supposed to. If you have data that you are concerned about, add in this secondary layer. If you're worried about compliance, you're worried about your audits, and you're trying to grow your business, whether it's regionally or across regions, I think we can add a lot of value and make your life a lot easier. So, we're here to help.
Awesome. Angelo, that comes down to us. We're pushing up the batting order. What's your final thoughts?
You know me. Complexity is the enemy of security, guys. And if I can make this less complex and easier to understand, it's easier to indicate that security it has good efficacy, and it's easier for us to say, hey, we can sleep at night a little better. The problem comes with complexity and adding many different layers to it that create needed double checks and such like that. So when I look at this, I look at, if I had this earlier, I probably would have had less gray hair. Just throwing it out there.
There you go. And my favorite saying is the best security device rests between our ears.
Mm-hmm.
We so choose to use it. So with that, I thank you all for attending and participating and sharing your insights. Until next time, thanks for joining us. Take care.
See ya.